Bestrophin is a chloride channel that is activated by calcium. In the absence of calcium, bestrophin is closed and does not allow the permeation of chloride ions. But when calcium concentration in the cytoplasm of the cell increases, calcium binds to bestrophin, changing the shape of bestrophin so that it can now conduct chloride ions. First, we'll look at the calcium-free form. Bestrophin is a homopentamer, meaning that it is composed of 5 identical subunits, each indicated by a different color. Each chain consists of several hundred amino acids. We are looking at bestrophin from the plane of the membrane, which is here. Extracellular space is above, and cytoplasm is below. Now we rotate the protein 90 degrees and look down the pore from the extracellular space. Each chain has 3 hydrophobic amino acids that stick into the pore, that act as a gate. Here's a view of these amino acids in 2 subunits, viewed from the plane of the membrane. Looking back down the pore, we will now color hydrophobic amino acids gray and hydrophilic amino acids blue. These hydrophobic amino acids, 1 isoleucine and 2 phenylalanines, act as a gate and block the chloride ions from moving through the pore. Although chloride ions have a diameter of 3.7 angstroms, and the diameter of the closed pore is 5.4 angstroms, the hydrophobicity of those amino acids repel the chloride, such that it is extremely unlikely for chloride to permeate through the channel when calcium is unbound. When we look into the closed pore, we can see the pore is very hydrophobic and narrow. Now, if we look at the calcium-bound form, we can see that this gate folds back, increasing the diameter of the pore to 15.3 angstroms, as well as increasing its hydrophilicity, which allows chloride ions to travel through the channel. Here's an animation that models this transition that allows chloride to move through the channel. But what exactly causes this movement? Here's the calcium-bound open form of bestrophin. The green spheres represent calcium, and as we can see, there is 1 calcium for each respective subunit. But where exactly does calcium bind? In order to find out, we can select all amino acids within 4 angstroms of calcium to see which of them the calcium interacts with. We find that the calcium interacts with the backbone carbonyl of alanine and the side chains of 4 polar amino acids. Calcium interacts primarily with 6 oxygen atoms from these amino acids, colored red. These oxygen atoms are partially negatively charged due to their high electronegativity, which allows them to stabilize the positive charge of the calcium. In this video, you have seen how the chloride channel bestrophin is gated open by calcium.